So in class today, we talked about the compound trig functions when it was the same trig function inside and out. Now we're going to look at when there's different trig functions. Essentially, we just need to follow order of operations. So work one piece at a time. So first do the inside, do the parentheses of the function. So this just means what is inverse sine of negative 1/2. And this equals angle. Sine is y. And sine equals 1/2 at pi over 6 is essentially our reference angle. And then since it's negative, for sine, that means it's going to be negative pi over 6 because we're looking first and fourth quadrant. So now we just finished the problem. What is tangent of negative pi over 6? Well, tangent is y over x. At pi over 6, y is negative 1/2. X is root 3 over 2. Solve that out. And we get negative root 3 over 3. So for these problems, it's very much do the trig function on the inside, then do the trig function on the outside. This one is very similar to the last one. The only difference is the last one had an inverse on the inside. This one has a normal trig function on the inside. Same process though. Do inside the parentheses first. So we find tangent of negative pi over 4. Well, tangent of negative pi over 4, y over x. So negative root 2 over 2 over root 2 over 2 gives us a negative 1. Now go to the outside of the function. We want inverse cosine of negative 1. So cosine is negative 1 at negative pi. So now this one's a little bit different because the inside, we're still looking at this first, but it says inverse cosine of negative 3 over 7. We have no idea what that is. So this is a problem where we're going to need to use triangles. And if you don't know the exact value, here is where the triangles come into play. So if we have inverse cosine of negative 3 over 7, essentially remember inverse trig gives us an angle. So we know we have some theta that is going to equal this inverse cosine of negative 3 over 7. Now if we switch this around, this is the same as saying cosine of theta is equal to negative 3 over 7. Now this looks like something we've dealt with. We know cosine is adjacent over hypotenuse, and we're negative. So if we're looking at negative cosine, we know cosine is only going to be in quadrants 1 or 2. So if it's negative, we're looking at quadrant 2. We have negative 3 over 7. Now if we just do Pythagorean theorem, we can solve that this third side would be the square root of 40, which is the same as saying 2 root 10. So now, in the end, we just want to find cotangent of this angle. Remember, here's the angle we're dealing with, just cotangent of theta. Cotangent is adjacent over opposite, or x over y. So we have negative 3 over 2 root 10. Rationalize that really quick. And we get negative 3 root 10 all over 20. So for these problems, draw a triangle to represent the inverse on the inside, and then use that triangle to find the outside trig function. Okay, this next set of problems involves the expression u. These look confusing, but they're really the same type of problem we just did earlier where we draw a triangle. So the whole idea of this, we're trying to take tangent of some angle, just like before. So now, if cosine inverse of u represents our angle, and just like we just did before, so theta is cosine inverse of u, go ahead and rewrite that. What that means is cosine of our angle is equal to u. Again, that's just using the definition of the inverse to rewrite it. Well, we can still draw a triangle just like before. So think of this, that's really u over 1. Anytime you don't have a fraction, you can create one. We have a positive cosine, so we're going to draw a triangle in the first quadrant. Cosine is adjacent over hypotenuse, so we get u for adjacent, 1 for the hypotenuse. Now, same as before, just use Pythagorean theorem to solve for your other side. So we need whatever y is. So we'll write u squared plus y squared equals 1 squared. We're solving for y. So we get y squared equals 1 minus u squared. Take a square root, and we get that y is equal to 1 minus u squared. So now we can just sub that in over here. So this side is 1 minus u squared. And now back to the original problem. We were trying to find tangent. Tangent is opposite over adjacent. So we have the square root of 1 minus u squared all over u. And that's your final answer. So for these problems, treat them just like the ones that had numbers. You're just taking that u, putting it over 1. Use the trig ratio on the inside to draw a triangle. Do Pythagorean theorem. And then find the trig ratio on the outside. Last kind of problem we're looking at on this sheet is the same idea as these last two, where we're using the substitution. And as this time there's a 2 in there. So this is actually going to be using a double angle substitution. So just think about it this way. This is the same as saying sine of 2. Remember, anytime you have an inverse trig, that represents an angle. So we're looking at a problem that is sine of 2 theta. Now we just came out of doing all of these identities. And our identity for sine of 2 theta was 2 sine theta cosine theta. So just like the previous two kinds of problems, we need a triangle so we can solve for sine of theta, we can solve for cosine of theta. So we get that triangle from this inverse tangent piece. So we know that our theta is represented by inverse tangent of 3/4. So now if we take this, rearrange it, that means tangent of theta is equal to 3/4. Now we can go ahead and draw our triangle. Positive in the first quadrant, tangent is opposite over adjacent, and then do Pythagorean theorem, and this is a 3, 4, 5 triangle. So now we can come back over here to our 2 sine theta cosine of theta and just plug in. Again, we already have our triangle. So we have 2 sine of theta would be 3 over 5. Cosine of theta is 4 over 5. Multiply straight across. Technically that's 2 over 1. You get 24 over 25. So for these problems, again, this deals with drawing a triangle, using that inverse function and knowing it represents an angle. Use that inverse function to draw the triangle and then just plug the pieces in, getting the trig ratios.